Okay, so hello friends, welcome to BISP Solutions, and myself Ashwin, and I am working as a technical consultant at BISP, and BISP is a tech company, provide technological solutions across the world. Now today's session, bootcamp session, will be an interesting session. Now see, imagine today we are discussing on convolutional neural network, CNN. Now what is this CNN, right? So first of all, let me explain you the what is the scenario, what's the problem, and what is the solution for that problem. Let's take an example. A company is having 1000 employees, right? Company is having 1000 employees, and their front face photographs are stored in their database, right? Image database. Now suddenly one day someone come to the company and he says that, okay, do you have this person as your employee? Now see, when there are 1000 employees, nobody knows each other, because they are scattered in different parts of the companies. Like for example, the company's head office is in America, and then the subsidiary is in India, one subsidiary is in Singapore. So how can we detect that this person's so suppose I am having a photo of an employee Peter, right? And now I go to that company, and if I request that please tell me the name of this person, or due to some investigation purpose, now in that case there must be some way that, okay, this person is not working. So now there comes this solution, CNN gives you the solution. So what happens in this, the image of a person is given to the machine, and that machine will check the database, image database, photo database, and then machine will check 99% if the photo is matched or the image is matched. Then the machine will tell that, oh yes, this person's name is this, and he has been working for this much time, and whatever his details that you demanded, these are the details. So image detection, the basic thing is image detection. When the name, the database, suppose I am having only photograph of that person, and I don't know anything about that person. Many times it happens that someone comes to you and he says that, okay, have you seen this person? So in large institutes or in large organization, the image recognition or the image detection problem, that is the main thing. The company, every company needed such a solution that just inserting the image of that, feeding the image of that person, no matter if the image is latest or the oldest photo, no problem. Suppose I am having my photo of January 2025, right, or January 2024, and if I feed my current image, yesterday clicked photo, still that system CNN is able to recognize that image, and that photo will be 100% matched with the that image which is in the database. And finally it gives you the yes output, yes, this person is working in this company. So this CNN gives you the solution for that. Now we are not dependent, like give me the complete detail of that person, his name, his age, his email ID, his phone number. No, if you are having the photo of that person, on the basis of that, among 1000 images, the CNN is capable in searching those searching and matching those that image with all those 1000 images, right? So how it is done? Now how it is done, that is what we are going to discuss today. For that, first of all, we need to explain computer vision problem, exactly how the computer looks on these images, how the computer see the images. Now there are three categories. First, let's talk about the classification, the binary classification. Suppose, is this a photo of egg or pizza? For example, when there is only one answer, right, in the image, if I am showing you an image, and if I say that what photo is this, either egg or pizza, now you will reply me only one answer, that either egg or pizza. So that is called binary classification, one thing or another. Second, object detection, where's the thing we are looking of. For example, if in a photo object is detecting, we are detecting the object. For example, if a car is that in the photo, so that is called the object detection. And third is multi-class classification, right? Multi-class classification means, for example, I am showing you a photo and I am asking you that what type of photo is this, whether it's a sushi or a steak or a pizza, what type of photo is this, right? So in this way multi-class classification is there. And here, what are the different sections in this image? Now one more classification is that is called the segmentation. Segmentation means, see, in a photo there are different images. For example, if I am standing in a park and in the back side of me there is a tree, and on that tree there is a koala bear also. So there are different objects in a photo, so we have to identify different objects in that image. For this, segmentation is used, right? Now see, computer vision inputs and outputs, right? As yesterday we have seen, we saw that how the numbers, handwritten numbers are detected. Same thing today we are going to see exactly how image is input to the machine, and how that machine takes that image and how it process on that image, and finally the machine comes to a conclusion that this is the image of this particular item, right? So this is what we are going to do today. So for that we have to understand a little idea of how internally the computer works. We don't need to go in depth, but exactly we need to have an idea exactly how it works. So see, here you can see computer vision inputs and outputs. First of all, this 224, this is the height, right? 224 pixel is the height, 224 pixel is the width, almost a square shape image. And C3 means color channels, RGB, right? So that is why this C is used. Now see, whenever we input anything to the machine does not understand, because as we humans we can see that okay, this is pizza, this is whatever item is there, but the machine understands the language of zeros and one, right? The binary language. But here we will not go that depth. Here you see tensor language. This CNN understands the tensor language. So first of all, the image is converted into the tensors, right? And in that tensor we apply predicted output, we apply some operations, machine learning algorithm, and the output is like this, predicted output. So predicted output is also given in the format of tensor only. Tensor is a matrix, right? So output is also given into the tensor, and then immediately the tensor is converted into the image. So this is how it works. Suppose you might have you might have experienced that there is an option of Google Lens, right? In many of your mobile you have seen the Google Lens facility. What you do in that Google Lens, you just open that, and suppose you see a flower but you don't know exactly what type of flower is this, right? So what you will do, you will just open the lens and you will click that image, that particular unknown flower that you have seen the first time, and immediately the Google will Google will say that okay, it's a rose or any other type of flower, whichever the name is, right? So how it does? So what happens in that Google Lens, this same CNN technology similar to that might be used, so that first of all the image is captured, it is converted into the tensor, and then that image is matched with the database, the universal database. In that database all the flowers will be matched immediately, and then output will be given into the part of tensor, and then you will see the answer, that whether it's a rose flower or the lily flower or the jasmine flower, anything, right? So same thing is done by the CNN. Now if you see here how the image recognition works, it it is done by using a convolutional neural network, right? So pixel of images fed as input, right? Now see, first of all, this is a hummingbird, right? Or we can say kingfisher. I think it is a kingfisher. Okay, so now this image, the bird image, is fed into the machine. Now this is called the input layer. Now at the very first layer, it is converted into the tensor. Now inside that there are 2 or 3 hidden layers, right? So with the help of these 2 or 3 hidden layers, I will explain you in this session later. So after these 2 or 3 hidden layers, what they do, they process the image. Exactly what type of image is this? So it will work with the colorings, right? Color, and it also breaks the image into the into small parts, and then it finally it identifies, okay, what type of image is this, and then the output layer is the last layer that gives you the data into the format of tensor, right? And then the tensor is converted into bird, right? So these are called the hidden layers. Now if I show you what is CNN, the convolutional neural network is a type of deep learning neural network architecture commonly used in computer vision. Now see here, suppose if you see this bird image, right? So what happens, a very small part is taken, right? And then convolutional plus ReLU function plus max pooling, all these 3 functions are internally connected with each other. They work together, and finally see here, fully connected layers. These are the fully connected layers, and with the help of these 3 layers, final decision is taken. If you see here, let me give you one example. Many times at the time of Gmail creation, right, email creation, you are asked to fill that the computer shows you 5 to 6 images, and then you are asked to see click on those images containing only bus, or only those images containing only bird, so that to prove that you are not a human, you are not a robot, right? So in this way there are so many applications for which CNN is used, right? Now let's move ahead. See here, layers in convolutional neural network. So very first layer is convolutional layer, second is ReLU layer, third is pooling, and fourth is fully connected layer. So these are the layers which are used to come to a conclusion that exactly whatever you have fed to the computer, exactly what was that. Now see here, the convolution layer is used to extract feature from the input image. Now see, if you see this, look at this, 1 1 1 1, then 0 0, then 0 1. Okay, then you see here, this is their algorithm on the basis of which this 4 is derived. Here it is shown. So look at this input data. Now see, input data is given you in the format of matrix, right? Now see here, this is another matrix. Now this 1 1 0 0, this one and this one, this 0 and this 0, and then this 0 and 1, plus 1 0 1 1, then 0 0, and then 1 1 1 0 1 1, right? And this becomes 4. So in this way, input data, then the kernel, and the convoluted feature. So this is just a internal mechanism, right? And here ReLU layer also works the same: input image, then the convolutional layer, and then rectifier. This is the function that is used in the back end. Okay, and here is the pooling layer. Again the same thing, maximum pooling means maximum number of maximum digit is taken, and here the average is taken, right? So this is how it actually works, right? Now if you see this full connected layer, how it works, we provide the image, right? Let me make it bigger. We provide the image pixel from the flattened matrix fed as input. Now you see here, now you see these are the output layer, these are the input layer. Now in the middle two, you can see here the the hidden layer, sorry, intermediate hidden layer, and the final is output layer, and then final decision is taken, that is bird. Clear? So now this is how the mechanism behind this is working. Now let me show you this. Let's come to the, today I am not going to show you the live copy and paste example. Why? Because this takes too much time to process, because it's a image processing program, right? So we are not going to do it practically live. I have already done this for you for your convenience. So today we are going to just understand exactly how this code works. Okay, now see here, you can see in the first import, first step one is the import library, right? Now this import library, see, whenever we need to work in Pytorch, we need to import the libraries, right? So here is the import torch, then torch.nn, that nn stands for neural network, right? Then you see here torch.optim, that is for optimization, torch.vision, datasets, transform models, and then torch.utils.data, that is data loader, data is loaded. Then you see matplotlib plt is used for plotting the image, right? Numpy np is used for calculation. PIL import image. Now PIL is used, PIL is a library that is used to read the image. Clear? Okay, now let's come here. Now if you see here, step 2, set up dataset using image loader, image folder. Now see, whenever I click on this data dir train, data dir test, I have already uploaded the folder. Look at this, this is the folder CNN, this SEG train and SEG test, right? So SEG train, SEG test, it is already there. Now see here, transform.compose resize 30 to 32 pixel, right? Resize, we are resizing to fit ResNet input, right? And after that transforms.toTensor. First of all the images, for example, I am having a image, and I will show you this example first. Look at this, this is the building, I am having this image. Now I want to detect exactly what type of image is this. We know that this is a building, but with the help of this CNN, how we can do? So first of all the images that in the database, first of all they are converted in, resized into the 32 pixel height and width. After that that is converted into the tensor, then load dataset. Now see, we are using 70% in the as a batch size, sorry, 70% as a training data, 30% is for testing the data. So train dataset, datasets.image folder, then here is the root directory that we have given. Similarly train dataset and train loader, right? So data loader, that data is loaded. After that test a dataset means the data which is not used for trained, and here we have written shuffle true bits, only that limited data should be tested, right? Not all the data. Similarly test a dataset, test loader, right? Train dataset, train loader, test a dataset, test loader, and here we have written the shuffle true, that is mandatory. Then you can see here class name train dataset dot classes. After that print classes name. Now see, classes name means buildings, forest, glaciers, mountains, sea and street, right? If I show you, let me show you this. I will show you in our next session. So if you see here, building, forest, glacier, mountains, sea and street, right? So these are the classes That means these are the folders that we are having, or we can say these are the test images that we are having. Class name, buildings, forest, glacier, mountains. Right now I have given the photo of building, correct? Now see here, we have created in the third step. What we have done, we have created CNN model. In the CNN model, what happens here? Kernel size 3 is taken. Why kernel size 3 is taken? Because it is mandatory. Then conv2d, this is a function which is used to process, right? And max pool 2d, kernel size we have given already. After that, nn.linear, we are not taking the linear data, we are taking here class name, right? And then we activate the ReLU function, right? Now let's come here. See, forward function is also created. Now in this ReLU function is used, right? And here if you see self.fs1x, this is a normal standard procedure, right? After that, let's see here, CNN model equal to CNN. So we have created the model that is called CNN model. Now the criteria is neural network cross entropy loss. Cross entropy loss is used here. Then the optimizer, we talked about optimizer, right? And here the optimizer is applied here. Now see here the step 5. What is the step 5? Train the model. See, steps are almost same in every procedure. You see in our last few sessions also we have seen, first of all the data is separated into train test, then we apply the model, then we train the model, and after that we create a new model, right? We get the what we say efficiency of that model. So same procedure during the among those same procedure, one is train model. Now in this train model we have given all the necessary information, right? Zero gradient, then you see here loss dot backward optimizer step, then you will see here the running loss that divide by 100. So finally epochs, if you go see, training means what exactly? Running the same system on a given condition to a certain number of time, then only you get the perfect result. So same thing is here. Here we are using only 5 epochs. That means only 5 repetitions is sufficient, because it takes too much time, right? I also tried this, but it was taking too much time. That is why I'm explaining you today like this. Now after that we have completed the training part. Now training is done. So now what happened? Now plot the training loss. Now plt.plot training loss, plt.title we have given batch this. Now see here, your loss is too much decreased, right? Here if you see, loss is decreased. Batch, this is the batch number. So we have got the chart that okay, yeah, this is the chart. That means whatever the prediction is there in this particular college, or whatever the prediction in this particular image. See here, we have given the image here. Now see, evaluate the test data. Now see, so far whatever we have done, that is for image testing, right? So now first of all we have to evaluate the test data first. So test data, we have to put the test data, some test data we put here, and then based on that evaluate model test loader. So that comes 80%. That means 80% is accurate. We are just checking the accuracy of that particular code. Okay. Now see here, step 9, prediction of a new image. Now prediction of a new image means this is the image that I have given, correct? If I show you image, right? So we have given the image, and then look at this building.jpg. Okay, so content is a folder, content/building.jpg. Now predicted class, whatever the class means those 5 types of folder images that we have. After that, predicted class equal to predicted class, and it has successfully predicted the building, right? Building, we do not know what we are giving currently. We can think like this, right? After that, function that is visualize prediction, right? So visualize prediction, then image path predicted class. So visualizing the prediction, exactly, suppose it has predicted, but now visualizing the prediction, that is plt image show, now predicted and the prediction, predicted class and the prediction, whatever she has done, then visualize prediction. Look at this, right? That means now suppose if I give just give me a second. Suppose if I give any other building image, right? Suppose if I, in the apartment in which I am living, if I take a photograph of that huge apartment, right? So what this CNN will do, CNN will take this image, whatever I have clicked now of my apartment, and it will compare that image with several thousands of image that is already into its database. Okay, and based on that only it detects. For example, if you give me a whatever image, and then I will first see that image very carefully, and then I will compare that image with my database, image database, and then I come to a conclusion, okay, yeah, this is the image of this particular. Same thing is here, we have given the building image, same this building image, and then this building is compared with several images. And then after finally after working too much on that, it comes to a conclusion that yes, it's a building. Okay, so let's have a quick recap first. Let me show you one more time. See here, first of all, what happens, just a second, look at this. First of all, what happens, this is the standard procedure. If you see here the hidden layer, inside that hidden layer you see the convolutional CNN neural network and the neural layer you can see here. After that, if you see here convolutional layer, what is this convolutional layer? We are just adding it, right? We are adding it, and then whatever the decision is taken based on this, that will be the final output, right? After this, you see here ReLU layer. ReLU layer does not use the negative values, it convert that negative into 0, right? So this is how this ReLU layer is working. Pooling layer are used to reduce the size of an image, right? After this, full connected layer, this is the standard way that the procedure is done, right? Now let's have a practical also, so just give me a second. Here comes, right? First of all, the important and necessary libraries are called. Then we see here we put the image test, whatever the libraries are given, right? Then test and train images are given here. Then we create the variable train dataset, train loader, and test dataset, test loader, right? Then after this, what we do, we check class name also, right? Then if you see, classes are 6, that is the buildings, forest, glacier, mountain, sea and street, right? And then we see the CNN model class, right, in which we give the necessary information, and based on that we come to the conclusion, right? We give necessary example data, right? So now if you see model equal to CNN model, right? Now if you see here the criteria is NN dot cross entropy loss. So this cross entropy loss is applied here, and then you see cross entropy loss, right? And then you see the optimizer, that means the optimization technique is used here. After this, if you see train the model. So training the model is a different thing, but whatever the training model is there, if you see outputs equal to modeling the inputs, and then loss equal to criteria output detail. So there are so many steps of code which is written here, and you can see here finish training and then training loss, and here you will see here training loss, the training model, the train data, and the test data. And here the epochs also running one by one simultaneously. Once these epochs finish training, then again we will see plot the training loss, right? So plt dot plot training loss, and then we have plotted the data. So this data is 80% accurate. If I show you here somewhere, 80% accurate. Now if you see the step 8 is evaluate the model. Now we are evaluating the model, right? We evaluated the model. So model comma test loader. After this, step 9, prediction of a new image. Prediction of a new image, instead of checking the image, I think that would be much better, checking the image, right? So now if you see predict image, load and pre-process the image, right? So image equal to image dot open, and then the image path, complete image path you have to provide, right? So this is called the predict image. This is called prediction of the image. So all these things are done to ease the human resources, right? For example, if it is easy to recognize, so see how easily it will help to the government sectors, like the forensic sector, or we can say the police department. Many times the police has to find out that okay, this person is in which department. So the higher authorities, they take the image and they share it with the companies, and then finally it is the information is extracted. So guys, this is a most important example. I recommend you to watch this video again and try to practice from your own, right? Don't use the same example. Try to recognize the bird's image, right? You can put, I have given the building image, you can put the bird image, but it should be into this database, right? For example here, or street, you click the photo of any street and then load that street image into this machine, and finally you will see the exactly how it worked, right? So this is how it worked, and predicted is building, and exactly we have given the building image only. So this is how it works. So guys, tomorrow we will see some other new topic, right? Today we will stop here, and tomorrow we will see some other more interesting new topics. And those who are new to this channel, please subscribe my channel so that you will get the the notifications of the new videos. Okay guys, thank you for attending the bootcamp session.